Hi. So after looking into the importance of chemical kinetics, now let's come to the main core idea, how we are going to look into or how we are going to define the rate of reaction. So let's consider a very simple kind of elementary reaction. There is a reactant A getting converted into the product B. And if we need to define the rate, very simple idea. So what happens in any chemical reaction? The reactants, they start getting consumed. Okay, reactants in any reaction, reactants start getting consumed. What does it mean? Technically, it implies concentration of reactants start getting reduced. Okay, that is the fundamental. But this is from the reactants. What about products? Products start getting formed, start getting produced. It simply means concentration of products start getting increased. It is so simple idea. As the reaction progresses, the concentration of reactant will start getting reduced, and simultaneously concentration of product will start getting increased. So simple. Okay, so how to define? Very simple idea. So the rate of reaction can be defined with this simple idea. How we, in physics, how we find out the rate of any motion of the body? We call it as a speed. Okay, so how we measure the speed? Distance upon time. Similarly, here instead of distance, we say change in concentration. Change in concentration of whom? Okay, that choice is entirely ours. Either reactants or products. That choice is entirely ours, please remember. Divided by time. And now you people have rightly guessed that the concentration of reactants keeps on falling. So in this case, we will say, okay, that it has to be negative because it will be -1. So I'll say, I'll express like this, what we call a differential form dA by dt, while this is from the reactant perspective, and from the product perspective, it will be plus because the product concentration keeps on increasing. That's all. Rate is so simple. Okay, and this is called a differential form. In maths, okay, we call it as a differentiation, that is like a derivative. So the same concept. How concentration of the reactant is changing with reference to time. So simple. Okay. And now, last but not the least, how to find out the units. That idea is again simple. So rates units will be Concentration, as we have seen many times, it is the moles per dm cube, and time, let's express it in the second. So moles dm cube second raised to 1 minus 1. So simple. Rate of reaction. These are the units: moles dm raised to -3 second raised to -1. Simple idea, very simple concept. Okay,